Question 2 then gives us the distributions of the heights and weights of a group of athletes, and part A asks us to find the probability that somebody is taller than 188. So I want the probability that H is bigger than 188. Now I'm going to use the long method here, the standardizer method. If you want to see how to do it on your calculator, then have a look back at question 1. So this is going to be the probability that Z is bigger than 188 minus 180 over 5.2, x minus mu over sigma. And this comes out to be the probability that Z is bigger than 1.538. And if you get your calculator and look this up, so Shift and 7, get you your menu. It's a standard, normal cumulative distribution function. So I want my lower value, I'm looking, let's draw this. I've got 180 in the middle, 188 up here, so I'm looking for this area. So I want my lower value in this case to be 1.538. Because I'm on a standard normal distribution, then my upper value of 5 standard deviations from the mean will be plenty. Sigma is equal to 1 and my mean is equal to 0. So this gives me a probability of 0.620. And then for part B, something similar. Part B says to find the probability a weight is less than 97. So the probability W is less than 97. So this is the probability that Z is less than 97 minus 85 divided by 7.1, x minus mu over sigma. So this is the probability that Z is less than, if you work this out, it comes to 1.6901. And again, you can look this up in your table. We've got 85 in the middle, we've got 97 up here, and we want less than 97, so we're looking for this area. So again, if you go back to your calculator, in this case we'll have our lower value as something like -5. We'll have our upper value as the Z value for 97, 1.6901. My mean and my standard deviation are the same, so this gives me a probability of 0.9545. So part C is asking for the probability that an athlete is taller than 188, so the probability H is bigger than 188, and the weight is more than 97. So this is going to be, well, this probability we worked out up here, so this is 0.620 multiplied by the probability the weight is bigger than 97. Well, we've worked out the probability of being less than 97 here. So bigger than 97 is 1 minus this, so 1 minus 0.9545. And if you work this out, what we end up with is 0.00282. And finally, part D says to comment on the assumption that the height and weight are independent. Well, this is unlikely. Height and weight are connected. So there's likely to be a positive correlation, probably a positive correlation. You don't need to say positive correlation, you just need to say that they're linked in some way. And then again, if you want to do these just on your calculator without standardizing, you can do.